Hello! In this tutorial, I will discuss the concept of HVAC loops. I will use a relatively simple hot water loop as an example to highlight important aspects of the loop. Other loop types and individual component details will be covered in later tutorials. I will also show you how to manually connect HVAC loop components. HVAC loops are used to model mechanical ventilation systems, hot and chilled water piped distribution systems, condenser water distribution systems, and VRF refrigerant and heat recovery systems. A loop is divided into two subloops, a demand subloop and a supply subloop. Here is a simple representation of a hot water loop. The demand subloop contains the zones and their zone components, where conditioning is delivered to meet the demand. This creates a load on the system, which is met by the HVAC plant in the supply subloop. This schematic diagram, created in Designbuilder, represents HVAC components connected by pipes or ducts to form the various water and air distribution systems. This one is a schematic of a centralised air-based conditioning system with a variable air volume supply and zone reheat. The working fluid is supplied at the required set points and volumes by the plant in the supply subloop. It is then sent to the demand subloop, where the required heating or cooling loads in the zones or the domestic water systems are met before the fluid is returned to the supply subloop. At the HVAC system level, you can see the different loop types available in Designbuilder by clicking on the Add Loop icon. The various loop types are also shown here in the info panel in their respective groupings. Here we have a model with a single zone group. Before adding a loop, I will add a hot water radiator to one of the zones, which automatically adds it to all zones in the group. I will zoom out using my mouse scroll wheel to provide space to position the loop next to the zone group. I will now add a hot water loop to create a simple hot water heating system. The hot water loop can be used to heat and distribute hot water, components such as heating coils in air handling units and zone terminal units. To add a hot water loop, I simply select the option here in the toolbar with a left click. Move my mouse to an appropriate position on the layout screen, and left click again to confirm the position of the loop. Once the loop is added, you can see it in the navigation panel as well. Whilst in the HVAC system, you are always at building level in the model, as shown by the level indicator at the top of the layout screen. The navigation panel shows which level you are at within the HVAC system itself. I will navigate to the hot water loop to see it in greater detail. The default hot water plant supply subloop includes a single boiler, flow splitter, flow mixer, and a circulating pump. The splitters and mixers in the supply subloop provide the connections to enable you to add more boilers. The grey dashed line between the splitter and the mixer represents a flow bypass. The supply subloop also includes a set point manager. The position of the arrow on the set point manager symbol shows that it is controlling the flow temperature in the supply subloop shortly after the boiler and supply mixer, just before it enters the demand subloop. I won't cover it here, but please note that there is also a very useful heat exchanger component in Designbuilder, which provides the versatility to connect different systems and transfer energy between them. I will now connect my loop and zone components. I make loop connections from the demand subloop here, which now also shows the radiator component connections. Selecting the Connect Components icon and moving the cursor onto the end of one of the lines representing the pipework, you see a green snap point. It doesn't matter which end of the loop I start, but I must connect the supply and flow sides correctly. There are arrows available to help you identify this. After selecting a node, I move the mouse in the required direction to enable me to draw horizontal and vertical lines. Drawing guides help me to quickly locate existing endpoints, so I can simply left-click to define a change of direction, then left-click again on the radiator snap point to connect that pipe. After connecting onto the supply or flow node on the demand subloop, another splitter is added automatically to enable me to collect more components if necessary. I will repeat the process to connect the return water flow path. Once all the loops are connected, you should go back to the HVAC system level and check the schematic. This finishes our quick review of adding loops and connecting components in Designbuilder. If you want to learn more about the topics introduced in this tutorial, including top tips that will improve your modelling efficiency, then our Introduction to Detailed HVAC and Introduction to HVAC Hot Water Plant Loops on-demand online training session explores this in more detail. We hope you found this tutorial useful. Further information on the specific topics and wider application areas can be found in the comprehensive Designbuilder program help, other tutorials and webinars, and our on-demand training.